Hallo zusammen. Anyone in English? Just in German? This is not feasible. In English, please? Okay. Woo. Oh, cool. Okay. No mother tongue in German. Okay, now it's in English. Okay, we do have a meeting now, and it's Max Körbächer from Liquid Reply, and he will tell us about how to cloud-native technologies transform teams. And I could imagine it would be very interesting because I already had a talk with him, and it was quite nice. So have fun and enjoy your time.
Thank you very much.
Okay, then take mine.
All right. Perfect. Thank you. Yes, I will talk about a little bit about cloud-native technologies. So normally I'm giving a little bit more technology-oriented talks. So I try to give my best to make it not too complicated, but maybe to get a small warm-up. If I say something about Kubernetes, how many people would understand me? Already? Okay, that's good for the beginning. Good that I have a slide and a good recommendation for a book where you can read a little bit more about it. It's really friendly for the people. So my name is Max Körbächer. I'm co-founder of Liquid Reply, and we are specialized about Kubernetes implementation. We are basically building abstraction layers on different kind of cloud providers, on vSphere, actually wherever you want to have, on the edge devices, not in cars, we've clarified this earlier in the discussion, but anywhere else where you would like to have it. I'm also contributing to the Kubernetes. It's an open source project. I'm part of the release team since nearly 2 years, also part of the release engineering team, and struggle a little bit with bringing 40,000 people's contribution to one single software. But it's a good experience here and there. So actually this talk was designed to have together with a customer of us, because actually this is a side product, the transformation of the team which we saw. Originally we came there to implement and shift the application to the cloud provider and just ensure that it runs smoothly. So a few years ago, we basically met a product owner and his engineer, and they started very simple. As I said, simple software, a little bit of virtual machine, that's it. During this time, we faced many challenges. The IT people could not access any kind of cloud resource from their local computer. So they need to bring their own devices from home. Maybe now you know why they do not want to be named publicly. And we figured a way around to, do not need to use a VPN anymore, so we can directly access the cloud provider, also within the network from the company, and so on. You see, there are some challenges here which we have and need to work around because the organization stuck in the old manner of how to do IT. And that was a big issue. Sometime later, the team has grown just a little bit, slightly, but they come out with a total different people, I would say. When you saw them in the beginning, when you saw the team afterwards, they have changed. They have a different mindset. They were fast in implementing things. They were really fast in testing different kind of tools out. When you throw them some topics on the table, they need just a couple of days, maybe a week to understand how it works, have implemented, and maybe phased it also out again. So they completely changed within this short time. And this little team was able to implement a solution which is global scaling, used in B2B and B2C use cases, and have several hundred thousands of requests per hour. And it runs stable with any kind of downtime, which is great. So what actually happened? As said, our initial use case was like, hey, we need to just bring this application a little bit to the cloud provider, and that's it. But there happened so much in this journey, and as said, it was a little side product which we saw. So to answer this question, we will take a short look on what is actually cloud native, because this is sometimes not very clear what does it mean. We take a look on some points which we have discovered is a real challenge and which we have seen also in other customer and clients, that it's a pattern which pops up again and again, which we have to solve during our journeys towards a Kubernetes platform. And then finally, what needs to be done that the teams can really adapt to such kind of technology, to the speed of the technology and the complexity. So as said, this is the logo of Kubernetes. Maybe you now know it. It's a little bit much spread around the internet. Sometimes we need to hear that Kubernetes is the answer on everything. It is not. Also, I love to implement this tool, but we need to really think about if it makes sense or if it doesn't make sense. What you can imagine about it is that Kubernetes is a kind of operating system for different cloud provider and infrastructure. It's not like the operating system like Windows or Mac. It's actually abstracting the whole APIs of the systems. Everything what needs to be or can be spoken with, Kubernetes can somehow utilize to distribute new applications, to distribute infrastructure and so on. I try to put it somehow a little bit in more business words, but it's the same which you get always promised if you move to cloud or use any kind of SaaS product. You have a faster time to market, you can make some cost optimization. We talked about it earlier. Cost optimization just happens if you kick out some other stuff and optimize your tools. But, well, that's the unique selling points of it. You have scalability and availability if you do it right. If not, you just have a really big waterhead where you're stuck to, and you cannot really proceed on it. Your cloud and infrastructure providers are very neutral if done right. There's always this like, hey, if you go to containers and use Kubernetes, you can deploy it everywhere. That's a lie. Theoretically, it will work. Practically, you have to implement one-to-one the same thing that it somehow will work. So it's a little challenge. And yeah, it's a good entry point to a single IT, to a single cloud provider. If you want to really get to know more about it, there's a really good book, which is and was crafted and designed by actually a colleague or friend of mine who was with me in the release team, Karen Chu. It's the illustrated Children's Guide to Kubernetes. And there are a couple of more of these books. They're very nice and pleasant. So the title is a little bit like poking the people, but it's very good. And there's a few more which really try to explain the concepts which are behind and what Kubernetes should really help you. And then we need to talk about cloud native. The bad message is if you do cloud, you're not cloud native. You are maybe natively to the cloud provider. You maybe have understood the cloud provider, but you're not per se cloud native. Maybe accidentally, maybe not. The characteristic of cloud native, what if you take a look about, there are tons of Wikipedia articles and other stuff where you can basically gather this information. So it's like, okay, we have somehow an unreliable infrastructure which we need to deal with. The applications must be able to scale and should be stateless. We utilize and declaratively APIs. So I write a piece of paper, basically, what I want to have, and the tool takes care that this appears like I want to have it, which is awesome. We use it all the time. Makes things way more easier than to code it down. Some people say if you go cloud native, you're talking about containers or serverless. I would not necessarily subscribe to it. You can do also other things with it. And yeah, I would put it like Michael Dell said it. The cloud isn't a place. It's a way of how you're doing IT. And this is really explaining also what is cloud native. Cloud native is not about all these cool fancy tools and whatever promises you have. It's really about thinking how I can do things so that they're, well, faster in the implementation, which can be replaced because the technology change every now and then. The patterns change very fast and so on. Or in the other words, the way how you do IT till today, or most likely most companies do it till today, I built a platform, then I took the whole team out, and one single man is standing there with thousands of servers and needs to maintain them somehow. And the point where he goes to vacation or is getting sick, you get pretty much into trouble. This is not what you want to have. So this is a cloud native landscape from the Cloud Native Computing Foundation. It covers maybe 20% of all the open source tools around Kubernetes, which are helpful. There's way more other stuff. There's some premium freeware, however you want to call it. And we operate a couple of clusters and platforms. And what we see is that you have around about 160 updates which you need to run, and around about 46 CVEs which you have to close, just within 6 months. Or in other words, every day of the year, you need to fix something in the system. And if you're not good with doing the automation, bringing your software to the platform, if you do not trust in how reliable the platform is, and you cannot automatically stage all these changes, you will pretty much have an issue because you have a really huge operations overhead. And that's something which you need to solve and which can be solved if you have a team which adopts to the cloud native tools. So to put it more out, when we are talking about cloud native, we mean on the one side that we are building platforms based on Kubernetes, wherever you want to have it. My colleague always says we meet the client where the Kubernetes is, so can be everywhere. We solve the problematic situation about application delivery. How do I get my software from a piece of code running maybe on some local computer? Meanwhile, it's also running in containers in GitHub and whatsoever, wherever the people start coding, and get a compiled application down to it and get it deployed. Automation, I just highlighted it as a very important part of it. And we need to use everything about declarative APIs. Again, so we basically write down, I need to have a system with XYZ databases, a couple of hundred of nodes, an entry point in the DNS, whatsoever. Sorry for getting too technical. Click a button, it takes 10, 15, sometimes 50 minutes, depending on which cloud provider, and you get it all ready. This is where we want to be. And why we do all these things is to build a foundation where we can really trust on throwing all kinds of applications to it, which can run reliable, which is really fast, which is able to be automatically updated, and even can be metrics-based updated. Means that we basically can throw any kind of change, and as soon as some of the metric information, like web requests, are getting worse, we can roll back in a certain update. So this way, we can really automate everything, and we do not need anyone or not so much people to keep things somehow alive or keep them up to date. Now we know everything about the terminology, which I will use here and there. And what is actually with cloud native going on? We have seen three common patterns, which in actually all kind of projects which we are doing are getting problematic. The first thing is the complexity. The complexity of the market. You have seen the CNCF landscape. These are a couple of hundred of tools, plus every week comes 1, 2, 3, 4, 5 new tools to the market. The major issue is that every tool solves exactly one problem. It's not like in the past where you bought a Microsoft bus server, which can do everything. No one knows how it works, but it can solve everything. But nowadays you have one tool solving exactly one problem, and you need to find this one tool if you have a problem. And that can be a kind of journey. And if something really doesn't fit, most of the tools nowadays are designed to be really extensible. So you can bring your own implementation, your own templates, your own code to it. The community, open source, hopes that you even contribute back to it and keep the things more extensed. And basically solve your problem and give it to the others. About the speed, I talked already a little bit. There are so many changes. If you do not automate, you're getting lost. You're getting really lost in all the things coming up, in all those issues coming up. If you have a regular release process, you would even not be able to deal with it. You can release it, and the day where you have released it, it's already outdated. You can actually throw it away because it has tons of security issues. You skip maybe 1, 2 major versions in the worst case. And even if you just think about Kubernetes, we currently release it now with a new release cycle 3 times per year, a major release. This means lately after 1 year, the version you have introduced is outdated, not supported anymore, and you need to throw it away. For a platform which is basically abstracting away the whole complexity, you need to learn to deal with it and to automatically replace some changes like this. And yeah, open source. Understanding of licensing is always a topic. When do I have to contribute back? Which changes needs to be contributed back? What I can use, what I can't use? I will not go further deep down into it. I think it's more kind of legal and philosophical discussion that every company needs to decide for themselves. There's basically most of the time no paid alternative or the alternative are not very good supported. So the benefit which you get is like, okay, maybe you can call someone, maybe you can write a ticket. I think it's most of the time not very helpful. And that leads to, you have to operate it. And operating IT nowadays is very costly. You need to have somewhere else an IT operations center which can run this stuff for a good price. Because who, for example, we came from Munich, who with a master in computer science wants to operate 24/7 on a weekend system? I don't know, I have never met one. I cannot answer this. Alrighty. As said, normally this talk is even a little bit more technical. I try not to go too deep into it, but when we take a look on the complexity, with many tools, this also means that there are tons of dependencies which needs to be managed. And so it's not like that only just the one tool solves one problem, but the one tool which solves one problem needs maybe also another tool to be operated. And so you build a chain of dependencies which you have to introduce. If you do everything wrong, you have absolutely no control about the versions. And if you have a standard cluster with like 20, 30 components, and they all run in latest, you have a cluster which automatically keeps things updated and sometimes break even the implementation of your tools. What we try to do to teach the teams is to basically utilize what you already use for implementing Kubernetes or declaratively files, for example, using policies. So most of the time we are starting on a green field. There doesn't exist something. But think about just you put sheeps on the green field, in 1 hour they all disappeared because they do not have any borders, no boundary, they just will run away. So what we use is heavily policies, policy engines, which keeps already some boundaries and allows us that even so that maybe someone do not have enough experience to work with this, cannot break out of this context anymore. And yeah, finally, release management. It sounds always like a boring job. If you have several hundred things which you need to update, it's actually quite a busy job. We have the speed and the evolution of the tools. As said, as soon as you build something and you release it, you actually need to plan the next release. Or if you do it like some companies already really try to figure it out, you basically plan already the next 2, 3, 5 releases even before you have the current release done, because you need to. This can be solved if you keep focused on automation. As said, there's enough stuff which gets every once, twice per week updated, and you can actually run per default updates on it. And you can stage it automatically through your whole system. Really important, stay informed, because the whole market changed continuously. Concepts which were 1 year ago really cool and fancy are nowadays outdated. How many time you spend to implement CI/CD? Bringing up Jenkins and whatsoever. For the second part of the CI/CD, the continuous deployment, you actually don't need it anymore because the concept has changed. You now do a pull principle, GitOps. You don't want to throw it anymore over, you want to that the cluster or system automatically pulls the updates. And this just happened within 2 or 3 years. And last but not least, open source. We talked already about it shortly. There's no service provider. There are breaking changes. Somehow the open source community do really great jobs, also in breaking things. So when they write somewhere, this is a breaking change, it means it will really, really break something. We have seen it a few years ago. There was a Kubernetes update from 1.18 to from 1.8 to 1.9. There was written, okay, if you make this update, it maybe will break your cluster. In fact, it basically broke all cluster worldwide because the database changed, version update in the schema, and the API changed. It breaks basically everything. So it's something where you need to be careful with. And if you have automated it and make it declaratively, you can control it so that the change maybe will break something, but hopefully not your productive system. Alrighty, sorry for this little technical flyaway, but why all these things is important is that modern teams who needs to operate this kind of platforms needs to keep in mind tons of things. It's not just like, I need to update my operating system in 16 months, because then I maybe need to renew also the license. But you have many changes all the time, continuously. And the team which we had in the beginning allowed themselves to really take care about it and allowed themselves to test out and try out things. So rather than they stick purely to a timeline where they have to implement something, they stumbled from one system to the other system until they found out what suits to them. So they, maybe make their baby steps, you can say it like this, and really slowly grow into this like, okay, there's always another solution which I can use. There's always something which maybe fits a little bit better. It's maybe doesn't have so much functionalities, but it's good enough for my situation. What is quite interesting and what we have observed besides this, we had at the same time multiple projects doing basically the same cloud run. And another project implementing the same solution just for another continent was actually decided to being implemented with us, but then for cost reasons, center, whatever problems, they did it by their own. And they stick to the old processes. They didn't allow themselves to take a look on Kubernetes and all the open source tools. They didn't manage to work around all the hurdles which they have organizational-wise. They go into production nearly half a year later. The team, instead of having three techies and a product owner, had 9 people in the end. Sometimes the project was even above 15 people for running one application. It's already sick. They had all the time problems. Everything was outdated. As said, normally we do this talk with our client together, but now you maybe know why they do not want to be named, because it's not so good when you're operating some stuff like this in this way. So cloud native teams, or teams who are thinking cloud native, can be really effective. And this is not only just about technology. That's why it's difficult to say like, I'm on the cloud and that's why I'm cloud native. No, you have the right mindset. You adopted your mindset. You do the things differently, and that's why you're cloud native. Not because you use some tools. Just because I'm using Kubernetes, I'm not cloud native. I'm just a guy who uses Kubernetes maybe. And what is more important in it, when you use or adopt to this mindset, you're also getting used to doing continuous changes. We had a few years before another big project, and the product owner was very cool in one thing. He was like, I do not care if the things break as long as you can fix it again, because I want to fail so often that you do not want to fail anymore. And this was a very, very great approach, because we fall so often, sometimes we were like, I do not want to do it anymore. But we got to the place where we were so comfortable in the end about releasing new versions, deploying it to different continents, deploying it in different various sizes, exchanging some tools in it, and we were still confident it will run. And this is where really the mind change happened. But this mind change doesn't happen within one day. There's a project of 2 years with over 90 engineers. It's huge, but it happened after a while. In Munich, we run also the Kubernetes meetup, and also therefore we meet other people from other companies. And as you maybe know, there are also a couple of unicorns running around. Tech companies like Celonis, like Personio. What is very interesting, they have teams, platform teams of maybe 5, 6, 7 people. They run systems where, on the one hand side, hundreds of software developers contribute to and continuously extend the functionalities of the systems. And on the other hand side, have hundreds and thousands of customers on the same systems at the same time running. But the team which, over all of these things, operated is never bigger than 10 people. And this is crazy when you think about. We heard before, like, okay, hey, maybe you run an SAP system and you need 5 departments with 50 people per department. Well, it's a different mentality. It's a different approach how you do IT or technology. I think it says for itself. On the one side, you need to really have an idea where you want to go, and on the other side, you really need to take the tools into an account and trust sometimes into the tools and also into the community to give you the chance to adopt it. And then you can also have the chance to adopt your mindset. So the 3 major takeaways. When you build solutions and you want to adopt to the cloud native environment, then trust in it that the only thing which is always continuously be there is that the change will happen. There's nothing which you will once implement and will stay like this. Never. If it is like this, your business is dead. And then you do not need to think about digital transformation or whatsoever, because what do you want to transform if you do not move, right? Target for the useful things, not for the full use case. It's a big lessons learned which we always see. When we implement a tool, it's always like, yeah, but can we not use this other tool? It can do more. Okay, but why you need more if you just need one little single functionality in it? Always a big discussion. And foster the adoption of cloud native, especially when your processes actually do not fit to it. On the one side, it makes the most fun when you continuously run against your organization. But from time to time, processes within the organization will be bent and will break. So it allows you that you can maybe go to a new way. How many IT organizations are there which cannot go from their local computer to any kind of cloud provider? They are forced by their own company to break their own laws, their own rules, to do their job. This cannot be the thing, or? And that's why, run against your own processes and maybe you can adapt the cloud native. So, long story short, why this is important and why this is important for cloud native, for transformation, for digital transformation and for innovation. We do very technical stuff. And if you do not build platforms which supports your continuous change, which support you in being faster and develop things, which support you in adopting maybe new technologies, then you will not build any kind of USP anymore. You just will use someone else's system, someone else's software as a service, and with this you cannot differentiate. You do not win anything out of it. You just do what you have done ever before. So also the really technical, bloody, nerdy part is very important for doing the digital transformation, beside all this fancy stuff like Agile and Scrum and whatsoever. Q&A will be later. Thank you very much.